All right, welcome back. Today we're going to continue and probably finish up with encapsulation and our discussion on structures. Remember that we are live on YouTube. If you have questions, you can use the chat feature there, but it'd be better if you use the live Q&A on Piazza. So what I want to do today is I want to go over everything that we did last time. But I want to, last time we did basically a tutorial. We just designed I think it was a book structure that went along with an author structure and stuff like that. I want to go through that code one more time, fix it up, clean it up a little bit. And then as we're going along, I want to highlight what we did and why we did it in the notes as we go along. So first of all, here are our structure definitions. Typically, structure definition should go in a header file, along with all the prototypes that act on that structure. So what I'm going to do is I'm going to create a header file, and I'm going to move everything over there. Let's say it's a film or it's book, so I'm going to just go ahead and make book.h. Right now, there's also going to be a person in there. There's also going to be a date in there. You might want to separate those out into date.h and person.h if you really want to. I'm not going to go that far for this demonstration, though. Oops, I want to move book.h into code and then move into code. There we go. Sorry about that. There we go. So I'm going to take all this stuff and move it over into this book.h file. All right. Now, strictly speaking, you should also be doing documentation. This structure, actually, that's redundant, models a date using the year, month, and day, right? Something like this. You could put doc-style comments above each one of these to pretty much tell people what this is, what the purpose of this thing is. Also, remember that order matters. Why did we go date, person, and then book? Well, because person was composed of a date as well as two strings, a first name and a last name. So in order to have a date, you have to have defined it first. So remember the order matters. And these generally go into a header file. So again, I think we already made these observations, but let's go over composition refers to when one structure owns another structure. Order matters. You must declare a structure before you can use it in other structures. And typically, structures are declared in a header file. Okay. Now, we also had a bunch of functions that we defined that acted on that book. Like given an ISBN, a title, an author's first name, last name, and the number of pages, we had a function here to create a book. This is called a factory function. So what I want to do is I want to move these functions over into a source file and then make sure that I put all of the prototypes in the header file, right? So touch book.c, right? Hopefully, there we go. So I'm going to put all the definitions over here in the C file. Also make sure at the top here, at the top that you have an include, everything that you need. Include book.h, right? What else do we need to include? Well, we're doing malloc and we're doing string stuff, and we're also doing, I think eventually we're going to be doing input and output. So the same stuff that I had up here in the demo is going to need to be included in the source file over here. Right? We're still seeing people make the basic mistake of including source files. You never do this. In no example have we ever done this. We've only ever included header files. Right? It is wrong to include a C file. You'll get different behavior, and especially if you include the file again and again and again, you'll have multiple definitions of the same stuff. Right? I don't think I copied over everything. So yeah, I'll need to move all this stuff over too. There we go. Now I'm going to go ahead and temporarily cut and paste all this stuff into the header file, but that's only in order to get all of the prototypes. Right? All prototypes belong in the header file. Now at this point, I would be losing points if I submitted this. Why? What am I not putting on at the top of each one of these? Documentation. Right? Documentation goes with the header files. There we go. Get rid of all of the bodies, and there we go. So I'll put in a to-do here, documentation, right? Documentation goes with the header files, in the header files with the prototypes. Documentation should also be put on each one of the structure definitions. And now we've got everything separated out into the proper files. Of course, over here I would include book.h. Right? So we left off with this right here, create a print books function. Before we do that, let's go ahead and take a look at the functions that we've already done. First of all, I have this nice convenience function. Doesn't have anything to do with books at all, right? This deep copy string function. Highly recommend that you make something like this and start using it. We're still seeing a lot of errors where people are using the assignment operator to assign string values. You cannot do that, okay? We've said this many, many, many times, and people are still making this mistake. You can resolve that mistake simply by cutting and pasting and using this function as much as you want, all right? What does it do? It uses malloc to create a string of a certain size, uses strcpy to properly copy over the contents of one string into another, and then gives you the new copy right here, all right? We just did this because we did this over and over and over again when we created this book right here. This is a factory function. Why is it called a factory function? If I give you all the components of this thing, then you will assemble it, right? It's an assembly factory. That's what a factory does. A factory doesn't start with raw materials. They don't bring in iron ore and then smelt it and then go on and build a car. They bring in all that's a smelting factory, right? An actual automobile factory brings in all these pieces and then assembles them so that it creates a final car. In this case, we're creating a book. So this is called a factory function, right? So observation 2, using structures. You can easily create a factory function to help you create instances of structures, right? And we only did it here for the book. But of course, you could imagine creating factory functions for a person, factory functions for a date, whatever, right? We're separating those components out and giving author first name, author last name, and in fact, we skip some stuff here. Note the return type here. You can have pointers to structures, right? When you do, or you can use pointers to structures as you have with pointers to other variable types. Right? When you have a pointer to a structure, you use the, what did we call this thing over here? To access the member variables, right? B's ISBN, B's title, etc. What was this thing called? The arrow operator. Again, technically it's called the indirect component selection operator, because what this is doing is it's dereferencing the pointer, and then it's using the regular dot operator in order to access this stuff. But dereferencing with parentheses, dot, wow, that's 4 characters. I can do it in 2 characters, right? It's just a convenience thing. It's syntactic sugar. Remember that term, syntactic sugar, where it's not necessary. It's not absolutely necessary for the language, but it makes it, better, because sugar makes everything better, right? Sugar and peanut butter, but we don't have any peanut butter. Right? When you have a pointer to a structure, you use the arrow operator, the hyphen, and then the greater than sign to access member variables. Right? By the way, when you have a regular old structure, you use the, what was that called? The dot operator, right? To access member variables. Right? You can easily create a factory function like we did here, so that given the ISBN, the title, the author, it makes deep copies of all those strings for you, sets up memory for that one book. Oh, hey, there's another thing that we should observe. That once you've defined a structure, you can use size of to determine the number of bytes that the structure requires. Right? So, once you have created or defined, I should say, a structure, you can use size of, say book in this case, to determine how many bytes each one takes. Right? Again, compilers are dumb. but they are smart enough to count stuff up. And they see one integer, okay, that's 4 bytes. A double, oh, okay, that's another 8 bytes, right? And add all that up and you get 12 bytes, right? However many bytes it requires. Right? The compiler can do that for you, and all you need to do is use the size of macro. Okay? The factory function will take care of the rest for you. If you've got a regular old variable here, like number of pages, remember number of pages, that was just a regular old integer. It's not a pointer, so we use the dot. If we had book here in this case is a pointer, so we use the arrow operator to do that. But we don't need to use a deep copy string function because we don't need to set up memory. We already set up memory here on line 19, technically, right? And then we return a pointer to that thing. If I had just created a regular old structure, it would still have technically worked, but that's because there's magic going on under the hood that I don't really want to get into. It's a CPY that's taking over and doing the work for you. This chunk of memory that represents your book is being copied onto the stack, and then it's being copied over here when you use the assignment operator, and it all works. It's just that it works by magic, and you're copying a whole bunch of bytes instead of just, say, 4 bytes or 8 bytes, or if it's a pointer here, certainly just 8 bytes. Right? We also had this is kind of called a D structure, right? In object-oriented programming, we don't have we do have factory functions, but this is more often called a constructor. It constructs an instance of a book. What's the antonym of construction? Destruction. So this is a constructor, and then this is a destructor, right? If you want to free up a book, well, what needs to happen first? You need to free up any references it has to dynamically allocated memory. You need to free up the ISBN, the title, the author's first name. Why do we use the dot operator here? Let's follow the chain of events. Book star, that is a pointer, so we have to use the arrow operator. But once I'm in a book, then the author, it's right here. There we go. The author is a person. That is not a person star. That is a regular old structure. So if we've got author here, then it's going to be author dot to get to the author's first name and last name. Right? And that's why over here we use a combination of arrow, because we've got a pointer. But after that, author is just a regular old structure, so we use the dot operator here. We free up the first name, last name, and only after we freed all those things up do we actually free up the book itself. We don't have to free up date here. Why? Well, because it's just 3 regular integers. You don't free regular integers. Okay. If you did that, you'd get a segmentation fault. Because if the year was 2020 and you tried to free it, that would mean that you're trying to free memory location 2020. That probably doesn't belong to you at all. Right? All right. So then what else did we do? We had a nice convenience function here, book to string, that used a temporary buffer and sprintf to dump the title, the last name, and the first name all to a string and return that string. We also had this convenience function to print a book. Given a book by reference, it calls this other function to convert it to a string, or to get a string representation of it. It prints that out, and then it frees up that string. If I don't free up that string, what are the consequences? I was given a book. I got a new string. I filled it up, right? This creates a dynamically deep string copy right here. I print it out, and then I leave. What happened to this string right here? Memory leak, right? So let's make sure that we don't have a memory leak by freeing it up after we're done with it, right? I created it. I used it. I'm done with it, so I'm responsible for freeing it. Right? I being the print book function right here. Okay. All right. So other convenience functions, other common / convenience functions include a function to convert or to create a human readable string representation of a structure, right? A two-string function. Right? That's very, very common in object-oriented programming as well. Other applications of this, it doesn't have to necessarily be a human readable string. It could be a serializable string. Like, for example, you could take a book and then dump it to an XML representation like you kind of did for state data in lab last week. You could dump it to a JSON file for transmission over the web. You could dump it to a binary file so that you can store it in a binary formatted file, right? You could do a lot of other things with this kind of pattern. A function to create a human readable string representation, a function to, what else did we do? Sorry. A destructor, right? So, did I mention factory functions? Oh, yeah, I mentioned a factory function. A function to free up all aspects of a string, a destructor function, right? What else could we do? Well, I'm going to show you another alternative here, an initialization function, right? If you already have an instance of a structure and you want to initialize its values, right? In other words, it's kind of like the factory function, except less one step. You already have this structure. You just want to set all of its variables. What would that look like? How would that look different from this factory function right here? I'm going to go ahead and cut and paste this initially. First of all, I'm not going to create this book for you. I'm not going to create this memory. You're going to give me the book, right? So I'm going to make this into a void function initially, right? Now, you're giving me a book. Can it be const b book b? Is that's my here? Yeah. Can it be const, first of all? No. I'm going to be making changes to it. I'm going to be initializing its values. So, it can't be const. Now, you can give me a book, but what happens when you use just book B? It's not a pointer. It's being passed how? Is it being passed by value, or is it being passed by reference? Imagine that this was not a book. Imagine that this was just an integer. Is this being passed by reference, or is this being passed by value? This is being passed by value. If I change b, and now it's an integer, if I change it to 42, is that going to do anything to the calling function? Nope, because changes local to any variables in the parameters or any local variables are not realized in the calling function. So I can't do that. I would have to pass this by reference. Now we'll restore it and make it a book again. I have to pass this by reference. If you just give me a regular old book, fine, you're giving me a copy of the book. I'll go ahead and change that copy, and then the copy goes away. Your original book has never changed, okay? You still need ISBN, title, author, et cetera, et cetera, et cetera, okay? Can I call this create book if I want to keep the original too? Nope. It's an initialization function, so it's not creating anything. It's initting it. Init. That's a common shorthand for initialization. Okay? Now, what does it look like? I don't create it anymore. You gave it to me. So I've got everything that I had before. And then I don't return B, I just return. There. Now I've got two ways of creating things. Again, you don't need to do this. You don't even need to create a function to do this. It's just convenience. I've made it even more convenient and more flexible by, well, you can create it this way or you can create it that way. Sometimes you might want to create it this way. Sometimes you might want to create it that way. It depends on your use case. By creating both of these, I have some choices to make, right? Not only that, but wait a second. I see a lot of similarities. Well, not all those lines, but those lines and those lines all seem the same to me. What is that screaming out? Make another function, or I've already used them. I've already created the two functions, right? One of these functions can use the other function, and I don't have to repeat myself. DRY, don't repeat yourself, right? The dry principle. So, which one should it be? Should I have create book call init book, or should I have init book call create book? All right, create book call init book. Why? Well, because here we are creating a book, and all I need to do now is set all of its values. Init book, I'll pass in B, and everything else is just a pass through. ISBN, title, author, first name, author, last name, and number of pages. There. Now I'm not repeating myself. One function calls another function, right? And I'm reusing code. The whole reason that we create functions to begin with is for code reuse. That looks pretty good. Why did I only pass B here? Why don't I pass star B? Why don't I pass ampersand B? It's already a pointer. That matches that, right? If I did this, I would be getting the memory address of the pointer. Sometimes you want to do that. Not this time, though. If I did this, I would be dereferencing it. I'd be taking that book pointer and making it into a regular old book, right? That neither one of those is correct. It's already a book star, and it expects a book star. We're good to go. Let's make sure that I haven't made any mistakes or introduced any new bugs. GCC -C, and remember WALL, right? Book.c. There we go. Oh, I never had init book. I need to put that into my header file. And create book. I'll just it doesn't order really doesn't matter here, but there we go. What else? I think that's it. Yeah. Okay. Good. That was probably just a warning, I'm sure. And it came up because I remembered to use the WAL flag. Again, a lot of people that we helped today could have easily solved their problems by using the WAL flag. They were forgetting to return things from their functions, and by default, it's not going to complain about that because, well, that's up to you. That's your choice. All right, that's what the compiler. That's the attitude that the compiler takes. Correct the attitude of the compiler by using the WAL flag and forcing it to tell you those things. All right. So there's an initialization function. If you already have an instance of a structure and you want to initialize its values. Another one would be similar functions that act on arrays of structures. Right? For example, I think we had it in our to-do over here. Create a print books function. Right? So let me go ahead and do that now. We've got a print book function. Maybe we can reuse that. But before I do that, actually, one more thing I wanted to mention on the init. Remember that I made this into a void function that because I'm not returning anything. What could I do now that that's freed up? I could change that to an integer and then do what? To do error handling. Right. This is where I can start to do some. For now, I'm just going to leave it as void. I'll put it as a to-do. Change the return type to int and do error handling, right? But here's where you can enforce good data integrity. For example, if the ISBN is null, then that's invalidate. I'm going to refuse to create this book for you, right? I will return an invalid ISBN. Or since ISBNs have a very strict numerical representation, you could even do some more sophisticated validation and say, well, no, you can't have an ISBN that's 50 characters long, right? It expects 3 characters followed by a dash followed by 13 digits, right? Something like that. You could enforce data integrity there. We didn't do it, but the date, that's where you could start doing data integrity as far as dates are concerned. There is no 13th month. If you give me an integer value that's outside the range 1 to 12, I can return an error code. If you give me February and then you give me the 29th, then I have to check to see if this is a leap year, right? So you could do very sophisticated data integrity checks if you really wanted to with this kind of stuff. Right? I'm going to leave that as a to do because I don't want to do it right now. Right? Where was that to do? There we go. Somewhere. Okay, so it's in the other file. I will do this to do though. Create a print books function. Okay. Void print books. Right? The big difference here is, well, the S, right? What should it take as input though? What does an array of books look like? First of all, am I going to be making any changes to it? Nope. So let's go ahead and make it const. It's a bunch of books. Is that correct? That's just one book passed by value. Is that correct? I'm halfway there. Now that's a pointer to a memory location that stores a book. Think about this in terms of integers instead. If you want to print a bunch of an array of integers, that's an array of integers, right? Const int, that you're not going to be making any changes to it, star b. But what else do you need to imply that it is an array of integers, that there's more than one of them? If I did that, then that would be like a two-dimensional, right? That would be similar to something like that. What else do I need? A number that represents the size, right? The number of books that are in the array, right? That is passed by value because there are 5 books in this array. There are 10 books in this array. I don't need to pass that by reference, okay? That is, now let me change that to back to book. The only difference between these two functions is the implied size over here. Over here, we're only passing one book. So by the implication here is that since I'm not passing a size, the implication is that there's only one book in this array, right? There's only one thing that you should be accessing. Over here, the implication by putting in a size is that there are multiple things. It could still be 1, right? If size is 1. But if it's 2, 3, 4, 5, then there are 5 books in this array. Okay? Help me to write this function now. What should it look like? I could print the first one, right? Print book, right? Just reuse what you already have. Print book, given 1 book, right? Well, that's the first one, right? The second one, the third one. Should I be doing it like this? No, what should I be doing? For int I equals 0, I is less than size. The idiomatic for loop, right? For iterating over elements in an array. Don't print book 0, print book I. That'll print it out 1 to a line because that's what print book does. It takes care of freeing up that string every single time for me. Right? There's a little bit better way of doing this if we really wanted to do it, but this is pretty good for now. However, when I go to compile this, hopefully there will be a warning here. In fact, it should be an error. Yeah, good, error. Incompatible type for argument 1 of print book. Right here. All right? Now think of what books B is. Let me do this in notes. B is what? It is a book star. Book star. A pointer to a book. Right, book. Capital B. Right. Down here what I did is B sub I. So what is B sub I? It's just a regular old book. A regular old structure. Right. So at this point I could use the dot operator instead of the arrow operator. That's not what print books wants. Print books wants a pointer to the book that you want to print. So how do I do that? If I have a regular old book, how do I change it back into a pointer? Ampersand B sub I is a pointer to the ith book. Right. Now that is going to be compatible. Right. And let me try it again. GCC. There we go. Now it's happy. Right. I'm going to leave this in so that you have it in the notes. This is not something that should ever appear in your final code, though. Right? This is lecture note comment documentation. This is not real documentation. Okay. All right. Let's try to use this stuff now. So I've created my books. In fact, I'm going to change all this to do initializations. And so I'm going to init book instead. Init. Right? And when I do that, instead of having a book star, I would have a book regular. So B1, B2, B3, oops, and change all of these. I'm just showing this to you so that you can see how you actually use this now, right? Now, let me go ahead and get rid of this stuff first. There. Now, is this going to work? GCC book.o with demo.c. Again, same exact error here. B3, B1, B2. What are those things? Oh, actually, what am I doing here? B1, B2, B3. There we go. It's not returning anything. This is a void function now, right? There, that's what I wanted, right? But I'll still get the same errors as before, right? Incompatible type for argument 1. What is B3? It's a regular old book. Init book requires, and I don't think I can do this, but, oh, wow, cool. All right, you can do it. So, cool trick learned today. This is something that most IDEs support, by the way. If you hold down the command button and click on something, it takes you right there to the declaration, right? Most, like Eclipse does this with the same one. Now, Windows users, I don't know what it would be. You can tell me if it's Control or something like that. Control or Alt. Control, right? And ISBN. Wow, it takes me even to the declaration of the structure. Cool, the ISBN within the structure. So again, review. Command or maybe Control on a Windows machine. Hover over something and click on it, and it takes you to that declaration. Very, very convenient, right? But anyway, to go back to the issue at hand here is that it requires a book pointer. If I have a regular old book, what do I need to do to make it into a pointer? Ampersand, ampersand, ampersand. There. Now I can put that into a library, right? An array of books. Int n is equal to 3. Book library of n. Okay. And then I can even assign these things if I really wanted to, doing something like this, B1, B2, B3, right? Just like I assign the prime numbers, the first 7 primes to a declaration, you can do something like this and it will work. No? All right, fine. May not be, it is initialized. What are you talking about? Fine. Do you like that one instead? Okay. It may not have been initialized. I'm sure that it was, and that's why these are just warnings. A.out, and of course it'll run, but it won't do anything because, it's just creating these things and putting them into an array. But now if I want to actually print out the entire library, print books, then I can pass in library, which is an array of books. How many are in there? N, 3. And run this again. And there we go. Shakespeare for Squirrels, 1984, Iliad by Moore, Orwell, and Simpson. I forgot we did that. Homer Simpson by the Iliad. Right. Okay. This is icky. Why is this icky? It's a static array. We don't like static arrays, do we? Right. So let's do this proper and create a dynamic array of books. Book star library, right, equals a call to malloc. Size of, how many do you want? Size of book, and how many do you want? N, right? There we go. And then, of course, I can assign these each one. B1 of 0 is equal to B1, or not B1, but library. There we go. B2 and B3. There we go. And print books. It should still work in the same manner. There we go. Still works. All right. Here's an alternative way. In fact, what I'm going to do, I've done everything that I wanted to do over here. So what I'm going to do is I'm going to take these and put them in the notes so that you have them. And then, so there's that one. That is in book.h, right? Book.c will have the following contents. I'm just copying these over again for the notes. And then demo.c version 1 will be whatever I've got here. Oops. There. So those are all in the notes now. I want to change and show you an alternative way of handling all this stuff. Okay? Actually, before I do, yeah. What does this look like? Right? From an array perspective. Each book is, you know, a certain number of bytes, right? If I'm creating 3 books, all one after the other, this is all in contiguous memory. In fact, let me pull up the Python tutor's visualization here, and let's see what this looks like. Oops. I'm going to have to copy over a lot, though, to get this to work. Not book.h, but I'll bring over the structure definitions and anything else that I need. The init. And what else? Thank you. Deep copy string. Because I use that. Create book and init book. I don't need anything else, I think, for now. I'll just get rid of, yeah, that's all I need for now. Right? Let's hope this actually works. Whether or not it works, the key here is that it is allocating contiguous memory. Here's one book, then immediately right after that is another book. Here's the visualization of this. Oh, that's cool. I don't know if they changed that for Halloween or what, but they were using the poop emoji before, and now they're using the skull emoji. Cool. All right, so let's go ahead and run over this. 94. So after this is all done, you see that here's the structure. Here's book B1. Here's book B2. Here's book B3. I also like this visualization because it drives home the point that it's composed of other things. The ISBN is a character pointer that points to some array in memory of characters. But the author here is another structure that contains first name, last name, which are also pointers, but also it contains yet another structure within that has a year, day, and month. Right? So next. I wish I could just go with deep string, blah, blah, blah. There we go. All right, we're on the author. Maybe if I just speed it up to the last. All right, yeah, that's good enough. All right, so what does library look like? There. All right, so there's B1, B2, and B3. And then here's library with its own copies of everything. Everything is repeated over here. There's one after the other, right? An alternative would have been to have this book over here in memory, another book over here in memory, and another book over here in memory, not necessarily contiguous. And then what I could do is I could have an array of pointers. The first one would point to that one over there. The second one would point to that one over there. And the third one would point to that one over there. What might that look like? So let's go ahead and get rid of this. And let's instead have an array of pointers. Book star. Actually, let me go ahead and start not N3. I'll keep that one. Library of pointers instead. What does that look like instead? It kind of looks like a two-dimensional array of books. It's not like a two-dimensional array of characters. It's not like a two-dimensional array of integers, though. It is the first dimension is a bunch of pointers. 1, 2, 3 pointers. Each one of those is pointing to another thing in memory. Okay? So what does that look like? Well, we have a return type of a pointer to a pointer. Malloc, instead of doing books, you're doing book pointers. Okay? Now, if you create each one of those 3 things in memory, then all you need is pointers to it. So library of pointers of 0 is equal to, can I set it equal to B1? B2 and B3? Let's find out what the compiler has to say about that. Come on. Nope. Library of pointers. What is that? Again, let's go through that same exercise that we did in the other function. Library of pointers is a book star star. Therefore, library of pointers of 0 is a what? Book pointer, right? B1 is a book, capital B book, right? It's just a regular old book. So how do I make the left-hand side and the right-hand side compatible? What do I need to do? Ampersand, ampersand, ampersand. That gives me a pointer to this thing in memory that I can now make the first one point to this thing, the second one point to that thing, the third one point to that thing. And let's make sure that this compiles before I try it. Yep, good. I'm going to take this and modify just those lines of code. All right, let's see. Oh, I don't want to save it. Let's visualize this execution and see what it looks like. It's no longer going to be a contiguous allocation of books. There's also not going to be two separate copies. Remember, there was B1, B2, B3, and down here there was library 0, library 1, library 2. Now what is it going to look like? I'm going to jump to the end here. I've got B1, B2, and B3, but here's my library of pointers. When I look at that, I've got now a pointer back to the first one, right? I've got a pointer to the second one. I wish it was still red, right there. I've got a pointer to the third one. Right? It's a little bit more complicated, especially to keep it all in your head, but what might be one advantage of doing it this way instead? Saving on memory. Now there are not two copies of everything. You're not relying on the under the hood magic of memcopy every single time you make an assignment. Another advantage is, say that I didn't have 3, but I had 3 million of them. And when I run this, come on, there we go. Oops. Oh, darn it. I wanted a print function, but let me go back up to where we had it. There we go. All right. Is there an alternative way that you might want to print these things out? I printed these out in the order that I created them, right? What's another order that you might want to print these out in? Alphabetic order according to title. Alphabetical order according to author. Maybe by publish date. Now take any one of those 3 and reverse them. Zermello first, and then alpha down here, right? The newest to the oldest, or the oldest to the newest, right? There are many ways that you could print this out. If you had an array of pointers and you needed to sort it, and this book are out of order, right? This book comes after this book. I need to swap these two things around. If it were a big, giant, contiguous array of structures, that means I have to take this entire structure, copy it, take this entire structure, copy it, take this structure, and copy it back over here to swap them. But what if they're just pointers? Now all I have to do is take this pointer, and swap those pointers, which are only 8 bytes, right? Versus however many bytes this book was. Now, 40 bytes doesn't matter that much, right? 40 bytes, 50 bytes, 100 bytes, even a kilobyte is not anything to go, start crying about. But imagine that you had a much larger structure. Imagine you had a structure that had other structures and other structures and other structures, so that now you're talking about maybe 10K, 100K. Maybe you were actually storing the entire data of the album like as an MP3 or a book. You're storing the entire content of the book as well. Now it's 10 megabytes of data that you are copying, 10 megabytes of data that you are copying, and 10 megabytes of data that you are copying, right? Versus if you just had an array of pointers, now you're only ever swapping 8 bytes, 8 bytes, 8 bytes, 8 bytes everywhere. It has the potential to be a huge speed up, right? Not only that, but once these things are created in memory, they never move. Only the pointers to them move around in memory. Once these things are created, that's it. They're in memory, they're stuck in memory, you're not moving them around at all, right? That means far fewer cache misses, means huge potential speed ups in performance, right? And this is something I just show you. Now, when you go to do your own structures, we're not expecting this way, right? We are expecting the other way. If you want to do it this way, great, good job. Go ahead. We'll help you. I'll help you personally on that if you want to resolve it that way. We're only expecting the usual straightforward way that I showed you already. This is just another way of looking at it if you want to get deeper into it, right? And of course, it does require that you think about memory a little bit more, right? So I'll put this into the notes as alternative, right? Alternative, right? You can use arrays of pointers to structures to potentially speed things up and save memory. Right. And here's the example that I just did. I'll make sure that that's in the notes here. There. Okay. All right. So there was a question about which IDE. I'm using the CS50 IDE here, right? Most IDEs will do something like that, right? What's that book declaration again? Hold down that button and jump to it, right? What's that date declaration again? It jumps up to it. All you have to do is click on it. And this is why I've been trying to get people to use doc-style comments, because if you have an even more sophisticated IDE, I don't know, does this work? Nope, it's not going to work here. But if you use Eclipse, say next semester we'll be using Eclipse. If you use doc-style comments, then all that becomes clickable too, and you can hover over something and read the documentation in a nicely formatted manner. You can even follow links to external links to external websites to other documentation that doesn't even exist on your computer. Right? All right. Let's see. Any questions so far? No? Okay. What else do I want to... All right. So let's just, I guess, do a summary now. Oops. Summary. There we go. And move over here. And by the way, I use this as motivation for something that we're going to be talking about very soon. We're going to talk about recursion, introduce recursion on Wednesday. But after that, it's all the last topic, searching and sorting, right? Which is the biggest topic. We take 2 or 3 full weeks 2 weeks to go over it. All right. Why? Because it's so fundamental to data processing. The very first step usually in processing data is to impose some sort of order on it so that you can start to process it in a straightforward manner. Right? Not only that, but once you've sorted it in some manner, then it becomes super efficient to search through it using something called binary search. Okay. All right. So summary. Principles of design. Right? When defining or designing a structure, think about the essential pieces of data, right, that make it up. Right? And this is kind of an object-oriented programming principle too. When you define an object, you have to think, what is an object? What is this thing that I'm trying to model in the real world? If you think about a person, well, what is a person? Well, in the context of, if it was a student, I would say, well, I need a way of identifying them. So, NUID. That sounds natural. A person has a first name and a last name. Oh, by the way, they also have a middle name, a middle initial, a title, a suffix, right? A preferred name, a dot, right? You can go overboard, right? Do you remember what that principle was called? Yagni. Beware of Yagni. I talked about this, didn't I? You ain't or aren't, if you want to be proper, but I like to use ain't because it's a colloquialism. You ain't gonna need it. All right? In other words, don't unnecessarily over-engineer your structures. Right? Over-engineer your structures. Right? Over-engineering is a very common problem. Well, not so common as under engineering, but it's still a common problem. There are applications where you do need to over engineer stuff, and you do need triple redundancies, quadruple redundancies. If you were going to the moon, you would definitely want quadruple redundancies on all of your systems, all of your life support systems. If you are designing a Hello World program, you certainly do not need a fallback if it doesn't print properly, right? I don't know, I can't think of a trivial example, but there's one, right? So beware of Yagni. But otherwise, you identify each field or member variable and its type, right? This is sometimes referred to as decomposition, right? You're decompose a structure into smaller and smaller parts or substructures, right? Just like we did with, well, we've got an author. Well, that seems like that's another structure. That's a person. A person also has a date of birth. Well, that's three things, so that seems like another structure, right? You're decomposing it into the structures until it is either trivially representable, like a date, right? It doesn't get much simpler than 3 numbers, or an ISO 8601 formatted string, or a Unix epoch time, a single number, etc. It doesn't get much simpler than that. Or a structure is already defined for you, right? For example, if I were doing this in practice, I would probably want to use date underscore t. That's provided, not s. That's provided by the standard time library, right? Instead of doing my own date, right? The only reason I didn't do it here was because I wanted to demonstrate proper decomposition and composition, but also because it's actually difficult to use. In your lab tomorrow, you will have to make the decision: do I represent a date as a string? Do I represent a date as something like this? Do I represent a date using the built-in date time? It's up to you, but I'm going to tell you right now, keep it simple, right? Use a string, because when you read an XML file from an RSS feed, it'll already have a date formatted string for you. Just use this. Just use it. Don't get fancy. Don't go overboard, because you ain't gonna need it, right? Don't reinvent the wheel. Again, if there is a nice and convenient structure already defined, use it. Right? The semantics of a real-world object, or entity, I should say, because we don't like calling people or pets or living things objects, will dictate design. Right? The semantics of real-world objects. I mean, if you just think about like we did with our exercise, what is a book? Well, a book is a title. A book has an author. Oh wait, maybe it has 2 authors or 3 authors or multiple authors, right? And maybe also authors have written books. So maybe I want to, model that, right? Again, you're getting into the weeds, and you ain't going to need it in that case, at least for this. But if you do have a situation where you need to model that stuff, you need to think about it, right? How am I going to model this stuff? Maybe instead of an author, it's an array of authors or array of persons that are authors, right? Something like that. And of course, again, don't over-engineer it, right? Yeah, that's my summary of how to design for objects. Now, usually, especially with your lab tomorrow, your hack that's coming up, I think you do airports or something like that this week. And of course, with your project, you're doing like bank accounts. It'll be pretty straightforward on how you should model your stuff, because we say a bank account has an account number and a balance and whatever, right? And so if we're dictating that design, then it's pretty straightforward on how you should do that. Right? Any questions online? Nope. Again, if you're posting about the hack, you'll need to make sure that you take that over to the full session. Right? No? Yeah, go ahead.
This isn't a question. It's just, I think what you actually have to do if you're on Windows, you have to like click it and then press F3.
Oh.
And give it definitions.
Oh, what do you mean? Like,
Like instead of command click on Windows, you have to click it and then press F3.
oh, really?
I think so.
F3? All right, so from the audience, we have consent that if you have to highlight it and then hit F on Windows machines, you have to highlight it and then hit F3.
Yeah, and then it brings it to the declaration window.
Oh, right there, yeah, it is F3. Right. Oh, that's terrible. There's no jump. You can't do like command or command alt,
Yeah, it doesn't do anything.
command alt maybe,
And
control alt.
nope.
No, shift alt, control, shift control alt.
Let me just press all the buttons. See what happens.
At some point, it requires more fingers than it's worth.
Press F3 or something. Just like right click and click definition.
Okay. Well, I'm done with encapsulation at this point. We do have like 15, 20 minutes left if we have questions about the hack. I don't know how many people would actually watch this live in order to get their answers before midnight, but one of the questions online about hack is the error checking part. You have to do all sorts of error checking. You have to make sure that stuff is not null. You have to make sure that the file exists. And if one of those two, I think actually that's it. But one of the issues, pervasive issues that we've been seeing today is people using or printing error messages. You never print error messages in a function, right? When you call square root on -2, it doesn't say, oh, I can't handle -2s, right? It's silent, right? It also doesn't crash the program. You don't exit as error handling. We've only ever exited in main if we don't have enough, command line arguments or something, enough input to even proceed. But in functions, if you only ever return a sensible value. So all the functions in hack 10 are returning pointers. And so the only pointer value that tells you something went wrong is null, right? And so you would return null. Here's a suggestion. Usually the Windows key is the same as the Mac key. So if you hold down Windows and then click the window key, I assume that holding down the window keys just brings up the Windows dialog. Yeah, you might have to remap that or something. For protein translator, do you take command line arguments as strings? Yes, that's the only way that you can take command line arguments. And the first command line argument is always the executable file name, but argvis of 1, that's the input file. Argvis of 2, that's the output file. The names of the output files, right? So it's not like you can that you can immediately start reading from argv1. Argv1 is just a string. Let's go back to this one. So if you don't know how to take in command line arguments, you might need to review, I think, module 2, right? Ask that question. We can go ahead and post the relevant video on that in the main section. Any questions on hack tonight?
Oh, I guess I can might as well ask it while we have time. So, for one of the Piazza posts, you said that we should include like documentation, our name, and then the date in actual protein translator file. But how I handled the protein translator was that I included the file utils.h file.
That's fine.
Okay, then.
I would still put an authorship on protein utils or protein translator.c.
Okay, so have it still like both in my utils and my actual translator file.
Yeah, an author, just an author header, yeah.
Okay, so don't actually say like what the program does.
Well, I mean, isn't that already in there? Did we not? If not, then yeah, the protein translator should have documentation on this program takes in a file of DNA and outputs a file of not amino acids. What are they? Proteins, right? I don't know any biology. I stole this from a biology book.
Good look at it and like I didn't expect for biology to come into
Exactly. So there's STEM or STEAM, right, to include arts. Um, I'll tell you a story. A few years ago, I made a concerted effort when we had homework exercises instead of hacks. I made sure that there was one like mechanical engineering with torque. It was just it was like basic input output programs, and so given the input for some torque, you had to compute the force of something. So you had some mechanical engineering. I did some finance, so compute the APY given the APR or something. I had some I had some physics, so half-life or something like that of radioactive isotopes, right? I made a concerted effort to pull a bunch of different things from different disciplines, even art or geometry or something like that, to draw or to at least come up with the coordinates for a regular n-gon or something like that, right? And so I made a concerted effort to have like 6 exercises with from completely different disciplines. And a student commented, I like the exercises, but they were all math. Like, what are you talking about? All math. There was one from mechanical engineering. There was one from electrical engineering. There was from, dot, dot, dot. And they go, but you know what? You're right. They are all math. Why? Because at the end of the day, every discipline is math. Right? Everything can be modeled mathematically. Even business relationships, right? That's a graph, right? That this thing is related to that thing is related to that thing, and how, right? So at the end of the day, everything is math. Right? Even computer science is math. It's a branch of mathematics. It's the study of computation. That's why it's such a nice area to get into, because soon is coming the day where you will not be able to get into, say, mechanical engineering without also being competent at programming. You will not be able to become an artist without some sort of programming background, because if you're limiting yourself to the tools that other people build. If you want to become an artist and build your own tools in order to do your own art or whatever, then you need a little bit of that background. You don't have to become a computer scientist to also become an artist, of course. I know very few computer scientists who are good artists, but the ones that are good artists, wow, they can draw a picture like none other. I can't. I can draw a stick man and that's it, right? But you can see how computation and even just material from a computer science 1 course is applicable to every discipline, and we're soon. I think when I begin this course, I always start with a quote from Isaac Asimov from 60 years ago or something, and he was asked to predict what does 2010 or 2020 look like, the world of today. What does it look like? And he said, everybody will be a programmer, right? And we're not there yet. He was a little bit premature. He was really kind of optimistic about that. But soon will come the day where no, you've got to have right now you have to have technical skills no matter what, right? If you don't know how to open up a PowerPoint and do something, you're not getting a job at all, for period. But you still need some technical ability. But in the future, you're probably the technical ability requirements will probably be write a basic Python program to export an Excel file and crunch the numbers because Excel doesn't do what I want it to do, right? Even right now, somebody who has those skills and goes into business administration or has those skills and goes into a data science position, they're going to get 30, 40, 50, or 100% more salary than somebody that doesn't have those skills. Right? So yeah, everything is math. The day that you realize that is the day that the world starts opening up. Let's see. What does the final look like for this course? Probably very, very much like the midterm will look. You'll have all day to do it. I don't even know if there's a final exam schedule out yet. There should have been a long time ago. I don't know which day the final is, though. Do you know?
I know for like some classes, because like my chemistry class, the date's already like set. It's like, yeah, I think it varies from class to class.
Okay. I mean, I was planning on giving 24 hours. I mean, I could even open it on Monday and let it go all the way to Wednesday if you really want to. I'm flexible on that. Of course, no collaboration on the final or on your project either. Recommended minors for somebody who doesn't want a minor in math.
It's minor, whatever you want to minor.
Yeah, math. So if you're a computer science major, you do have to have a minor. We're getting off topic here, but if you really want to know,
Much to be on topic with.
if as a computer science major, you do need a minor. It's the most common is math, simply because I think you have to take one more class, and you've got your math minor. Maybe it's two more classes beyond what's already required. But otherwise, just as a plug, the College of Business offers a business minor, which is kind of a breadth. You take a basic marketing class, you take a basic accounting class, a basic economics class, maybe it's even microeconomics and macroeconomics. So you take 5 or 6 classes and you've got a business administration minor. Maybe it's just a business minor, I forget what it is. So that might be useful, but of course you're taking 6 more classes. I don't know. If you came into college with less than 4 years of a foreign language, you're probably going to be taking 2 years of a foreign language, and then if you take 1 more or 2 more courses, you've got a minor in that language, right? So that's another option. I think we have a full Chinese language complement now. Maybe, I'm not sure. But of course we have, German. Somebody's taking German. Spanish, French, of course. Those are the 3 major ones. Japanese. What is it?
Yeah, I was gonna say
Japanese.
Japanese.
I think we might have a full Chinese complement now. It used to be they only had like 1 year, but now they have 2 or 3 years. I forget. But that I don't know. Another plug would be a robotics minor. The College of Engineering offers a robotics minor. First of all, you're taking already Computer Science 1. That would apply to the minor. But then you can also take a few Mech-E classes, mechanical engineering classes, and I think 1 or 2 electrical engineering classes, and you've got a robotics minor. That's not popular yet, but by telling you about it, maybe it'll become more popular. What else is there? College of Engineering doesn't offer very many minors, unfortunately. That might change in the future, but that's one of them. You can't get a computer science minor if you're a computer science major. I don't know. That's maybe other students have better recommendations, but those are the major ones that I know of. If you have an interest in physics, get a physics minor. If you have an interest in chemistry, then get a chemistry minor, right? All right. Well, that brings us about to the end. I don't know if there are any other questions. Get the string instead of using... is there any other way to get the string instead of using get file content? I'm not sure what that means, but I mean, that's what you're doing. You're loading the contents of a file up into a string so that you can conveniently then process process the file as a string. There are lots of ways of doing it. fgetc, fgetS, you can use those. In any case, what we see is people, the general approach that you want to take is you're going to have to process the file twice. You're going to have to go through and count up the number of characters so that you can dynamically allocate enough memory for that string. Then you want to go through it a second time to actually fill up that string. So likewise, the second one, you actually have to go through and count up the number of lines so that you can create a 2-dimensional array of strings of the appropriate size. If there are 50 lines in the file, then you need a 50 by up to 1,000 for each line, up to 1,000 characters for each line. So you're going to have to process it twice. As we've said on Piazza, you can use the rewind function. Some people have been using the FASIQ function because they found it online. Great, go ahead. Or you can open it up once, close it, open it up a second time, close it. That's fine too. Right? There are lots of ways of doing it. Or as my high school algebra said, there's more than one way to skin a cat. Right? You can go up or you can go down. You have to wonder how many cats he skinned though. All right. Then we will continue with recursion on Thursday. Good luck with your hack.